Hello students, this is a video on the topic tests for quant that we have at Bodhee Prep for you. The idea of these tests is once you've done the basic concepts of a topic, you can take these tests to see whether you're able to apply those concepts in a timed manner in a test or not. Once you go through a test, the video with the test will tell you the solutions and give you brief analysis of the kind of test it was, the kind of what would be a good attempt for that matter, and the kind of time that you would have put into that test. There are more than 200 topic tests that are available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make best use of these tests. This test is on quadratic equations. This is the second test on this topic on the app. And if I have to analyze this test very briefly, I'd say moderate level of difficulty. A good attempt here would be about 5 to 6 questions, net correct out of 10. So we might not be able to do all 10 questions, but at least of the overall 10 questions, if you're getting about 5 to 6 net correct after removing the negative marks, that would mean a percentile of about 95 plus. Ideal time for this, I would say, would be about 25 minutes, where I would be able to go through the questions and get my 5 to 6 questions correct. Towards the end, I'll tell you which questions I would have chosen. First, let us have a look at the questions. So question number 1 says, if one root of the quadratic equation x square plus px plus 12 is 4, while the equations x square plus px plus q has equal roots, then the value of q is. Now from here we can say that the product of roots, that is, suppose the other root for this equation is a, I can say 4 into a will be 12 by 1. So the other root becomes 3, 12 by 4, which means the sum of roots 4 plus 3 should be equal to minus p, which means p becomes minus 7. So here we have x square minus 7x plus q. If the roots of the second equation are c and d, we can say that the sum of roots is c plus d, which is 7. Since the roots are equal, therefore c and d will be equal. So we can say 2c is equal to 7 or c is equal to 7 by 2. We have to find the value of q. Q is nothing but the product of roots. So q will be 7 by 2 into 7 by 2, which gives us 49 by 4. I think a relatively easy question involving sum of roots and product of roots. Types of question that definitely could be attempted in exams as well. Attempt time for this question, I'd say, should be about 1.5 minutes at the most. A and B are the roots of the equation x square plus x plus 1 is equal to 0. So from here we can say the sum of roots. A plus B will be minus B by A, which is minus 1. And A into B will be C by A, which is 1 in this case. C and D are the roots of the equation x square plus 3x plus C. So C plus D can be written as minus 3. And C into D can be written as 1. So minus B upon A, C upon A. What is the value of A minus C, B plus D, A plus D, B minus C? I'm clubbing similar terms together first. So A minus C into B minus C into B plus D into A plus D is what I'm calculating. Now this will give us AB minus C into A plus B plus C square. A into B minus A into C minus C into B. So minus C common, A plus B minus C into minus C. Similarly, this will give us AB plus D into A plus B into D. So D into A plus B plus D squared. So if we substitute the value of AB and A plus B, we will get C square. A plus B is minus 1. So plus C plus AB. AB is 1. C square plus C plus 1 into C square plus C plus 1 into D square. A plus B is minus 1. So minus D plus AB. AB is 1. Now if we look at this equation, we can say x square plus 1 is equal to 3x. We know that a is one of the roots for this equation, minus 3x. So we c and d, sorry. So we can say c square plus 1 will be equal to minus 3c. When x is equal to c, this equation will be true. Similarly, d square plus 1 should be equal to minus 3d. So c square plus 1 can be substituted with minus 3c plus c remains. D square plus 1 can be substituted with minus 3d minus d remains. So this becomes minus 2c into minus 4d. 4 2s are 8 into cd. C into d is 1, and therefore 8 into 1 becomes 8. So the final value that we get for this expression is 8, which becomes the answer, option A. I will call it a difficult question because arranging these terms might create a problem, and it might not be very easy to see that what to do after this point. If we do not reduce the terms, we get quite a long expression which might be difficult to solve, and therefore 2.5 to 3 minutes to solve this question. Because of the calculation involved, I'm saying a difficult question. Fx is ax square plus bx plus c, where abc are certain constants and a is not equal to 0. It is known that f5 is equal to minus 3f2. So we first put it in this condition. f5 is given to be minus 3 times of f2. f5 will be putting 5 instead of x squared. 25a plus 5b plus c is equal to minus 3 into putting 2 in place of x squared. 4a plus 2b plus c. This becomes 25a plus 5b plus c is equal to minus 12a minus 6b minus 3c. So bringing terms on the same side, 25 plus 12, 37a plus 11b plus 4c is equal to 0. Next, 3 is the root of fx. Therefore, f of 3 has to be 0. Putting 3 instead of x, we get 9a plus 3b plus c is equal to 0. We have to find the other root of fx. Okay. If we multiply this by 4, basically, if we get the value of a and b, we should be able to find the other root because we have one of the roots, which is 3. So using product of roots, we should be able to find it. Now, if we multiply this by 4, we get 36a. 36a plus 12b plus 4c is 0. So 36a plus 12b plus 4c is equal to 0. This is equation 1. This is equation 2. I am substituting. This is 12b. The idea is to reduce a and b into the smallest term. So the closest multiple of 9 was 36, which is 4 9s are 36. Closest multiple of 3 to 11 was 12. 4 3s are 12, and c is 4. So from here we'll be able to remove 4. Now 1 minus 2 will give me 37 minus 36, which is a. 11b minus 12, which is minus b. 4c minus 4c is 0. 0 minus 0 is 0. So if we subtract 2 from 1, we get a minus b 0, which means a is equal to b, which means b by a is equal to 1. Since b by a is equal to 1, here the sum of roots will be minus b by a. Minus b by a will be minus 1, and minus b by a will be nothing but 3 plus the other root. Suppose the other root is alpha. So 3 plus alpha should be minus 1, which will give us the value of alpha as minus 1 minus 3, which is minus 4. So the other root of the equation is minus 4. We did not get the value of b, but we got the value of a and b, the ratio of b and a, which gives us the sum of roots. And since one root was known, we calculated the other root. So I'll call it a moderate level of difficulty question. It is straightforward to get these two equations. And from there, we're just trying to calculate the ratio of a and b. So multiplied by 4 will get you the next step forward. Solving time could be about 2.5 minutes for this question. If a and b are the roots of the equation, x square plus 7x plus 4 is equal to 0, and a is greater than b, find the value of 3 by 2a plus 7 whole squared plus 4 by 2b plus 7 whole squared. Let us first square these terms and see what happens. 9 upon 4a square plus 2ab, 7 to the 14. 28a plus 49 is equal to, plus 16 upon 4b square, similarly plus 28b plus 49. Now, if you look at this term, since a and b are roots, we can say a square plus 7a plus 4 will be 0, and b square plus 7b plus 4 will also be 0, because a and b are roots. So if we substitute a and b instead of x, we should get the equation. Now, comparing these two equations, we see that a and coefficient of a square and a, here is a multiple of 4, or 4 times the coefficient here. So let us multiply this by 4. From here we can say 4a square plus 28a plus 16 is equal to 0. And similarly, therefore, 4b square plus 28b plus 16 will be 0. So if we take this out from here, we get 9 upon 4a square plus 28a. 49 can be written as 16 plus 33. plus 16 upon 4a square, 4b square plus 28b plus 7 plus 16 plus 33. We know that this is 0. We know that this is 0. And therefore, we are left with 9 by 33 plus 16 by 33, which comes to 25 by 33. And therefore, option A becomes my answer. I think this is an easy to moderate question. The moment you square this and compare the coefficients, the question kind of ends there. Does take one step to realize this is going to happen. Therefore, about 2 minutes to attempt. And since this first step might be a bit of a trouble, we might not go in the right direction. Therefore, I'm saying moderate level of difficulty. The graph of y is equal to ax square plus bx plus c. Beta and alpha roots, okay, is shown below. It is given that mod of alpha is less than mod of beta. So if we take alpha to be 2, b could be suppose minus 3. That can happen. Which of the following is true? A is less than 0. Because the curve is downward opening, we can be sure that A is less than 0, which is true for all cases. B is less than 0, B is greater than 0, B is less than 0, B is greater than 0. Now, if we look at ax square plus bx plus c, ax square plus bx plus c, the sum of roots, the product of roots will be c by a. Product of roots will be c by a. We know that c by a is equal to alpha into beta. Beta is a negative term, alpha is a positive term. Therefore, c by a has to be less than 0. Also, a is less than 0. Since a is negative, c has to be positive for sure. So from here, we can eliminate this and we can eliminate this. A is less than 0, C is less than 0. Now we look at sum of root, which is alpha plus beta. Clearly 2 minus 3, because mod of alpha is less than mod of beta. In terms of the negative sign, or in term when we add this, since the negative term is larger magnitude, we'll get this sum of roots is negative. So alpha plus beta has to be less than 0. So from here we can say minus b by a has to be less than 0, which means b by a has to be greater than 0, multiplying by minus 1 on both sides, converting the sign. We know that a is negative. If b by a is positive and a is negative, which that means b also has to be negative, only then will b by a be positive. And therefore b is also less than 0. So the answer becomes a less than 0, b less than 0, and c greater than 0 for this question. I think this would be an easy to moderate question. Another way of looking at this question could be, if we take the roots to be, say, 2 and 3, or rather 4 by 2, 4 by 2 and minus 6 by 2. So the equation kind of becomes x square minus 6 plus 4 minus 2 by 2 x plus 24 by 4 multiply by 4 throughout. So we will get 4x square minus 4x plus 24 is equal to 0. We get the value of ABC. A is negative. So let us take the negative of this. I made a mistake here. I made a mistake here. The right way of doing this, I've taken the wrong signs. If we do take the roots to be 4 by 2 and minus 6 by 2, that means the equation will be something like minus of x minus 4 by 2 and x plus 6 by 2. Because x is equal to 4 by 2 means x minus 4 by 2 is 0. I'm taking this 2 so that we get an a value in front. So this will become this is equal to 0. So this will be minus x square plus 2x by 2 plus minus 24 by 4 is equal to 0, multiply by 4 minus 4x square plus 4x minus 24 is equal to 0. As you can see, a is negative, c is negative, b is positive. Even if we take the values, we'll get the answer. The only thing is a is negative is something that we know from the graph. So again, not a very difficult question, but solving time could be moderate, as putting signs in the right manner might be a little confusing. If both P and Q belong to the set 1, 2, 3, 4, find the number of equations of the form x square minus px plus q is equal to 0, which have real roots. Now for real roots, p square minus 4ac has to be greater than equal to 0. So p square minus 4q has to be greater than equal to 0. If we put p as 4, if p is equal to 4, This means 16 minus 4q has to be greater than equal to 0. So q could take values of 1, 2, 3 or 4. So this gives us 4 solutions. 4, 1, 4, 2, 4, 3, 4, 4. If we take p square, p has 3, which is 9 minus 4q is greater than equal to 0. 9. This has to be less than 9. Q could be 4 ones are 4, 4 twos are 8. So two solutions here, 3, 1, 3, 2. If we take p is equal to 2, p square becomes 4 minus 4q is greater than equal to 0. Only possibility for q is 1. So one solution here. If we take p is equal to 1, p square minus 4q, p will be 1 minus 4. Any value of q will be greater, will make this negative. So this will never be greater than equal to 1. So no solutions. Total number of solutions is 4 plus 2 plus 1, 7. Again, moderate level of difficult question at most. But I think since the numbers are small, whenever we have a question where we have to count the number of solutions possible, there are chances of missing out on numbers. But here we are given the numbers and there are only 4 numbers, 1, 2, 3 and 4, which are small. And therefore about 2 minutes, easy to moderate level of difficulty question could be attempted in the exam. Ram and Shyam were trying to solve a quadratic equation. Ram copied the coefficient of x wrongly. If Ram copied the coefficient of x wrongly, he got the constant term correct. Constant term C gives us the product of roots. So the product of roots would be minus 4 into 24, which is minus 96. Shyam copied the constant term wrong. So this person, Shyam, got the coefficient of x correct. Coefficient of x is sum of roots. So the sum of roots had to be minus 9 plus 13, which is 4. Find the roots of the original equation. So we need two numbers which have a product of minus 96, a sum of 4. From the options, we can clearly see, no, sum is positive. So the positive number will be greater. From the options, you can see minus 8 and 12 have a product of minus 96 and a sum of 4. So option D becomes the answer. Yeah, so easy question, not more than a minute and a half to solve this. Basic concept, easy calculation. Anand purchased X chocolates for rupees Y. Y is a natural number less than 5. The shopkeeper had offered to give him X plus 10 chocolates for rupees 2. Anand declined the offer, though it would have resulted in a saving of 80 paisa per dozen chocolates for him. How many chocolates Anand purchased? 80 paisa per dozen. So if we find out the cost of chocolate, cost per chocolate for Anand in terms of paise, Anand spent rupees Y into 100 paisa for X chocolates, paisa per chocolate. He was being offered 200 paisa and X plus 10 chocolates. So the saving per chocolate would have been what he paid minus what he was offered per chocolate. But we are looking at savings per dozen. So multiply by 12 to get the overall saving, which is 80 paise. Taking 112 common, we can say y upon x minus 2 upon x plus 10 will be equal to 80 by 12 into 100. 24s are 5s are 4 3s are. This is 1 by 15 basically. So y upon x minus 2 upon x plus 10 is equal to 1 by 15. Since 1 by 15 is in the standard format, I can say x plus 10 has to be a multiple of 15. And ideally, x also will be something like that. If we take x plus 10 to be 15, x would be equal to 5. So we get y upon 5 minus 2 upon 15 is equal to 1 upon 15. This gives us the value of y as y upon 5 is equal to 3 upon 15. 3 upon 15, which will give us y as 1, which is a possibility, natural number. If we take x plus 10 as 30, x will be 20. So we get y upon 20 minus 2 by 30 is equal to 1 by 15, which is nothing but 2 by 30. Taking this 2 by 30 here as well, we get y by 20 is equal to 4 by 30. This will not give y as an integer, so not possible. If we take x plus 10 as 45, x would be 35. Clearly y by 35 minus 2 by 45 being equal to 1 by 15, which is 3 by 45, will not give us an answer in a integer. Y by 35 will be 5 by 45, which is 1 by 9. 9 does not cancel out 35, so not an answer. If we take x plus 10 is 60, x plus 10 is 60. X would be 50. So y by 50 minus 2 by 60 is equal to 1 by 15. This can be written as 4 by 60. So y by 50 will be equal to 2 plus 4. 6 by 60, which is 1 by 10. Y will be nothing but 50 by 10, which is 5. But it is given that y is a natural number less than 5. Here it becomes equal 5. So anything beyond this will take y greater than 5. The only possibility is y is equal to 1, and in this case x is 5. How many chocolates Anand purchased? Anand purchased x chocolates, or answer becomes 5. I think this would, for me, would be a difficult question because there are multiple cases and two variables, one equation, and therefore difficult, and easily 2.5 to 3 minutes to solve this question, even provided that we are able to solve it. What is the sum of all possible values of a natural number n that satisfy n square minus 2n raised to power n square plus 47 is equal to n square minus 2n raised to power 16n minus 16? The first possibility is that the base is same, in which case the power has to be same as well. N square minus 2n, of course, is same. So the power is same, where n square minus 2n is neither 0 nor 1 nor minus 1. Or minus 1 can work, even and odd we'll look at. So n square minus 2n is neither 0 nor 1, but some other value, in which case n square plus 47 the power plus 47 has to be equal to 16n minus 16. This becomes n square minus 16n plus 57, 63. 9 sevens are 63. So n minus 7 into n minus 9. If we put the value of ns is equal to 0, which means n could be 7, n could be 9. If we put the value of ns 7 and 9 here, n is equal to 7, n is equal to 9 in n square minus 2n, we'll get 49 minus 14, which is a positive integer, 81 minus 18, which is a positive integer. So both these are acceptable values. The other possibility could be that the powers are 0 together. But that will not happen because then it will be a common value which comes at 7 and 9 only. Now, if the base is 0, that is n square minus 2n is 0, which can happen at n is equal to 0 or n is equal to 2. Because n square is n into n minus 2 is equal to 0. So n is equal to 0 or n is equal to 2 will also mean that 0 raised to power anything is 0, so both sides will be equal. So these two are also acceptable answers. 0 plus 2 gives me a positive value here. 0 and 2 gives me a negative value here. 0 raised to power negative is also, or any value that I get, minus 16 or 16, 32 minus 16 will still be 0. If we have n square minus 2n is equal to 1, which means n square minus 2n minus 1 is equal to 0. B square minus 4ac. 4 plus 4, 8. Now this will not give us a natural value of n because b square minus 4ac would be 2 square. 4 plus 4, which is 8. So root of b square minus 4ac will not be natural, so no solution here. Lastly, we check for n square minus 2n is equal to minus 1. In this case, if the powers are even for the value of n, we will still get both of them equal, which is n square minus 2n plus 1 is equal to 0, or n minus 1 square is equal to 0. Now, if n is equal to 1, n square minus 2n will be minus 1. Here we will get minus 1 raised to power 1. 1 plus 47, which is 48, which is 1. And here we will get minus 1 raised to power 16 minus 16, which is 0. Minus 1 raised to power 0 will also be 1. So again, this will be equal. So the roots that we are getting are 9, 7, 0, 2, and 1. 7 plus 9, 16 plus 3, 19 becomes the answer, option C. I think for me it will be a moderate level of difficulty question. We just have to make cases. But again, very easy to miss out on a case here and there. So 2 to 2.5 minutes to solve the question. Alpha and beta are the roots of the equation 7x square minus 6x plus 1 is equal to 0. What is the value of alpha plus beta plus alpha square plus beta square plus alpha cube plus beta cube and so on till infinity? E square is 36 minus 28 is 8. 6 plus minus root of, if you look at the roots of this equation, alpha and beta. 6 minus 28. 36 minus b square minus 7 plus 28. This will be 8 upon 7. So 6 plus minus. So alpha would be 6 plus root of 8 by 2a. 6 plus root of 8 upon 14 minus b plus minus root of b square minus 2ab upon 2a. And beta would be 6 minus root of 8 upon 14. Very clearly we can see that alpha is less than 1. Beta is also less than 1. And therefore, if you look at this series, it is combined of alpha plus alpha square plus alpha 4 up to infinity plus beta square plus beta raised to power 4 up to infinity. Both of them are infinite GPs with the common ratio less than 1. So the sum of an infinite GP where the common ratio is less than 1 can be written as first term upon 1 minus common ratio, plus for this it will be first term upon 1 minus common ratio, a upon 1 minus r. So this is the value that we have to find out. If we add, we'll get alpha into 1 minus beta plus beta into 1 minus alpha upon 1 minus alpha into 1 minus beta. This becomes alpha minus alpha beta plus beta minus alpha beta upon 1 minus alpha plus beta in bracket plus alpha beta. So alpha plus beta would be 6 by 7 minus 2 alpha beta would be 1 by 7 upon 1 minus alpha beta would be 6 by 7 plus alpha beta would be 1 by 7. So this becomes 6 minus 2. 4 by 7 upon 1 minus 6 plus 1, which is minus 4. Minus 4 by 7, which will give the value as, sorry, this will be not minus 4 by 7, I'm sorry. This will become, the denominator will become 7 minus 6 plus 1 by 7, which will be 8 minus 6 plus 1 by 7, which is 4 by 7 by 2 by 7, which will be nothing but 4 by 2, or 2 becomes the answer. Again, just two things to identify here. First, that the common ratio is less than 1, and therefore we can simply put the value for the infinite formula for the sum of infinite GP. From there, we're just looking at the sum and product of roots. So therefore, I'm saying easy. Calculation time might go up to 2.5 minutes, but overall an easy question. And therefore, if you look at the overall analysis for the test, moderate difficulty, 5 to 6 questions, net correct, 20 to 25 minutes attempt time. For me, the questions would be 1, 4, 5, 6, 7, 10. Which are these? Definitely doing this one, sum and product of root. This I'm not counting as an exam question because arrangement might be a little difficult. Again, this will not counting as a exam question because sometimes it does not strike that you just have to look at the ratio of A and B, not solve for ABC. I will be doing this. Squaring gave me the base from where it could have worked. Would be doing this as well because we just have to put the values and get the answer. This also because only 4 numbers were there, therefore I think easy question should be attempted. This is definitely an easy question, one of the most basic questions in quadratic that we can get. This again is for me is a difficult question because there are two variables, one equation, and that too ratio is there. It could be difficult to solve. Easy to miss out on cases, therefore not counting this question. This I would have done because just simple formula of infinite GP and then sum of roots and product of roots. Therefore, for me, my 5 to 6 questions will come from 1, 4, 5, 6, 7, and 10. And that should be good enough to get me a 90 to 95 percentile.